Shalom, my name is Delita Sumanggi. I am a student at the Manado State University in the Civil Engineering program. In this video, I will explain the important points of 3 chapters of a book titled Concise Environmental Engineering. Okay, go straight to the explanation. The main subject of environmental engineering are environment, ecosystem, sustainability or main problems and activities, remote sensing and environment, environmental risks, water supply, water pollution, solid waste, air pollution, sound pollution, climate change. Number 1, environment. The environment has different meanings in different disciplines. In environmental engineering, the environment is where we live. The environment is divided into 2 types. Number 1, natural environment. The natural environment includes all living things and inanimate objects that occur naturally in the area. 2, artificial environment. Artificial environments refer to man-made environments that provide arrangement for human activities, aid buildings, parks, cities, and supporting infrastructure such as transportation, water supply, and energy supply. There are 4 globes which are of interest to environmental engineering, which are referred to as lithosphere, hydrosphere, atmosphere, and biosphere. Number 2, ecosystem. An ecosystem is a living organism that includes biotics, plant animals, and microbes in relation to living abiotic components of their environment that interact a system. Dynamic ecosystem with networks of interaction between organisms that their environment, they are linked together through nutrition and energy flow. What is energy flow? Energy flow in an ecosystem is an open system that is not a dump cycle, is converted to heat and is lost for a purpose that is useful forever. There are 5 trophic and decomposer levels, which if included, they mark the end of the food chain. Level 1, plants of algae are primary producer. Level 2, herbivores are primary consumers. Level 3, carnivores are secondary consumers if they eat herbivores. Level 4, carnivores are tertiary consumers if they eat other carnivores. Level 5, apex predator are at the top of the food chain if they have no predator. Next, cycles that occur in the ecosystem. Nutrient cycles, part of a large biogeochemical cycle involving macronutrients such as carbon, nitrogen, oxygen, phosphorus, and sulfur, and micronutrients such as copper, iron, and sodium. In contrast to energy flow, nutrient flow is part of a closed system and their chemicals are recycled and refilled constantly. Oxygen cycle that describes the movement of oxygen in their main reservoirs, namely the biosphere, atmosphere, and lithosphere. Carbon cycle that describes the movement of carbon in the main reservoirs, namely the atmosphere, hydrosphere, lithosphere, and biosphere. Phosphor cycle in an essential nutrient for plants and animals in the form of ions and is a limiting nutrient for aquatic organisms. To see the movement of phosphor through the lithosphere, hydrosphere, and biosphere. Sulfur cycle. The most oxidized form of sulfur is sulfate, which is the form that is most easily assimilated by plants to be reduced to organic sulfur. Sulfur is a key component in protein, amino acid, and B vitamins in plants and animals. Once plants and animals die, bacteria convert organic sulfur to reduce sulfide and then to sulfate to complete the cycle. Next, eutrophication. Eutrophication, Greek eutropia, adequate nutrition, is the ecosystem responses to excess nutrients that stimulate excessive plant growth. Next, two types of nutritional sources. Number one, point sources, identifiably sources that are easily set. Two, non-point sources, diffuse sources, very specially which are not easily set. Next, specially nitrogen moves through strong channels, sewage pipe, and forms of drainage flows. Biodiversity is the level of variation in life forms at all levels of biological systems, like molecular organisms, population, species, and ecosystem, and is used to measure ecosystem health. Two main factors are considered when measuring biological diversity. One, Wild is a measure the number of different types of organisms in a particular area. The more species present in the sample, the richer the sample. Two, evenness is a measure of the relative abundance of various species that make up the wealth of an area. Next, causes of biodiversity are not evenly distributed. Temperature variation, rainfall, height, soil, geography, and the existence of other species. Next, the benefits that humans derive from healthy biodiversity that support ecosystem service include air quality, climate, carbon dioxide absorption, water purification, pollination, and prevention of erosion. Next, measures that can be used to protect and restore rich biodiversity, such as removal of exotic species, reintroduction of lost species, biodiversity banking, reduction of pesticide use, wildlife corridors, and resources allocation. Next, ecosystem service. Ecosystem service are the benefits to human society from many resources, for example, food, water, and process, for example, decomposition of waste supplied by natural ecosystem. Ecosystem services are divided into four categories. Number one, provisioning service, service setting, support service, and cultural service. Next, number three, sustainability. Sustainability is the capacity to survive. Sustainability measurement is a metric used as a quantitative basic for management of information about sustainability. Population growth is one of the big challenges for sustainable development. Science increasing population puts up additional strain on natural resources. Next, urbanization. Urbanization is the physical growth of urban areas as a result of rural migration. The city is known as a place of many services, for example, the university, hospital, theater, and centralized wealth. Things that need to be considered in immigration. Number one, water force. Water resources as as full water sources. The term water footprint is often used to refer to the amount of what amount of water used by an individual, business, community, or nation. 2. Energy. The word energy is used as a synonym of energy resources, and as a large part it often refers to substance such as fuel, petroleum products, and electric in general. Mathematic optimization is a powerful tool for environmental engineers to manage resources problems. That problem of optimization is the search for the best solution of all reasonable options. The objective function, the cost function for minimization, or the utility function for maximization is said to be optimized. Pollution is the entry of contaminants into the natural environment with adverse changes. Air pollution, water pollution, soil pollution, blah blah blah. Pollution can be in the form of foreign substance or contaminants that occur naturally. Pollution control activities including recycling, reduce, mitigate, prevent, and compass. That is all, and thank you, and see you in the next video. Bye bye.